Okay, let's take a look at another example, number 36. So x to the 3/2. So we're going to have a fractional export. So we've got to do a little bit of algebra before we can get started. Now 3/5 can be written either as 3 times 1/5 or 1/5 times 3. And the question is, are there any values that we have to worry about with the x's? And I claim the answer is no, because if we do the following, if I write this, the 3/2 as 1/5, so I'm using this form, 1/5 to the power 3, and then I write this as x to the 1/5 to the power of 3. The 1/5 means what? The fifth root, and then you cube that number. The other possibility is to rewrite, instead of writing it as 1/5 times 3, you write the 3/5 as 3 times 1/2. Then you take the x cubed and then you raise it to the 1/5. So this would mean the fifth root of x cubed. Now, do we have anything to worry about? No, if I take the fifth root of 0, that's 0. 0 cubed is not a problem. Or if I use the other form, excuse me, if I take 0 cubed and then take that to the fifth root of that, that's not a problem. Can I take negative numbers for my x's? The answer is yes. Look, I can take the fifth root of a negative number. I just get a negative number, I cube it, it's a negative number, not a problem. If I take the cube root of a positive number, that's the positive number. And so it turns out that no, there's no restrictions on this. So let's take a look at what our, move this up just a little bit. Let's take a look at how we differentiate this. Well, this is the power rule. My n is what? 3/5. So I bring the 3/5 down, I subtract 1. Common denominator is what? Fifths. So I have 3/5 minus 5/5, which is negative 2/5. So in other words, my first derivative is this guy right here. And notice I'm bringing the what? The x term downstairs, which flips the sign of the exponent. Now, we have a big problem here, because this could be 0, correct? There's nothing to say that I can have 0 here. If I try to set this whole thing equal to 0, this is a fraction. 3 times 1 can never be 0, so the only critical point is where? At x equals 0. Okay. So I could rewrite this, the 2/5, as the squared raised to the fifth root of that. And like I said, if x is equal to 0, we got a big problem. It's 3 over 0, which is not indeterminate, but it's undefined. So in other words, 0 is a critical point in the sense that it's undefined, the derivative. There is no critical point in terms of making this guy 0, because 3 is never 0. So what this is saying is we have two regions now. We're going to choose numbers to the left of 0, nice numbers, and to the right. Okay, so if I pick x to be a negative 1, I just put it in my derivative. Negative 1 squared is positive 1. And I take the fifth root of a positive number, which means it is increasing. Next, if we take a number nice to the right of 0, so we're in region 2, I put in a 1, square it, that's 1, the fifth root of 1. So all these guys are positive, which means it's what? Increasing. So it's increasing in region 1 and region 2. At this point, all we're asking is, where is it increasing, where is it decreasing? So for region 1, it's all the numbers from negative infinity up to 0, not including 0, because in this case we'd be dividing by 0. And then it's all the x's from 0, not including 0, all the way to positive infinity. All right, let's take a look at number 32. Problem, square root. In other words, I do not want this to be what? Negative numbers. So that means I have to, So when we talk about the domain, it just means what x's are we allowed to use. Well, in other words, this guy has to be non-negative, correct? So in other words, if I subtract the 1 from both sides, x has to be bigger than or equal to -1, or we could write it as x is to the right of -1. So in other words, we are only allowed to look at all the x's to the right of -1. So, same old stuff. You take your function and we rewrite it in terms of exponents, and now you have a power rule. So the derivative becomes what? You take the 1/2 down, you subtract the 1. Chain rule says take the derivative of this, but that's just equal to 1. Okay, so that means we have a -1/2, which we now bring downstairs. Now notice that we have to exclude who? -1, correct? So now if I look at this is a fraction. If I try to find the critical points in terms of setting this equal to 0, that's not possible because a 1 is not ever going to be 0. So let's take a look at what we have. The derivative is a positive number divided by positive number, which is positive, which means it's what? Increasing. Okay, so what this means is, now remember, we cannot look at numbers here that are to the left of -1. So in other words, all we could do is what? Look at number, it's increasing from -1, not including -1, to positive infinity. Okay. Let's do this. Let's do the next one.